The following program is brought to you by the Center for Educational Outreach at Baylor College of Medicine.
Did you know that our lungs are not made of muscles? If that's true, then how do we breathe in air? Hello, I'm Barbara Tharp, and today we're going to explore how the lungs get it done. Materials that we'll be needing: a regular old gallon milk carton, some plastic hose, like aquarium hose, some straws, a beaker, a marker or crayon would work also, and some Post-it notes. Now we've got to consider safety again. Make sure that the students follow all their instructions. They begin the investigation when you're ready. And with this one, make sure you're really careful not to spill water, and if so, to mop it up immediately. In fact, I recommend that you do this outside if possible. Have you ever wondered how much air your lungs can hold? Or what is your lung capacity? Is there still some air in your lungs after you breathe out? Does everyone have the same lung capacity? And do lung diseases affect how much air a person's lungs can hold? Let's watch the following film from a teacher professional development workshop to find out. Here's what we're going to do now. We've looked at how the lung basically works. Now we're going to look at what your lung capacity is. What your lung capacity is. With that in mind, we have some really important, expensive tools this time, though. I forgot to tell you. Milk carton, hose, beaker, but you can use anything, and a tub. Okay? Dollar store stuff, basically, or less. Okay. Now, what we're going to do is normally I have the students, and it's one whole math lesson usually, just to calibrate the jug. Okay? Just regular milk jug, and you can do it however you want to, but if you've got a kid that's driving you crazy, you can have them do it at 100 milliliters, and they'll be there for a long time. 40 times I'll be doing to fill this up. But we did it at 500, and so 500, 1,000, 1,500, 2,000, 2,500, 3,000, and this one's not it's about 4,000 milliliters to the top, okay? So with that in mind, that's the first thing they do. If you don't have permanent markers, also what I've done is you can use crayon on the side. Or you can also use masking tape. Put masking tape down the side and write on the masking tape with crayon if you want to calibrate it that way. But definitely it gives them a much better picture of what 4,000 milliliters looks like. Okay? Once you have it calibrated, then what you do is you're going to fill the milk jug to the top as far as you can. Okay? And put the lid back on it. Then you're going to put about, a couple of inches, maybe 3 inches of water in here. So you have water maybe to right here, okay? Then you're going to take this one. You're going to take this one and you're going to put it down so that the top of this bottle is under the water. Kind of like, when you're a kid and played in the bathtub and you could get air trapped in here. So we're going to have this one trapped so that no more water can pour out of it. It's under the water. It takes at least 2 sets of hands, if not 3. Once it's under the water, the other person pulls the top off underwater and sticks the hose in, one end. It's a little tricky. And you can, the best way to do it for mouthpiece is to use a straw. And so we stick a straw in, you can cut it off however you want to do it. Put a straw in there, and what you're going to do is have the kids take one deep breath and see how much, if I've got it, let's see, would you come up here and help me? She's holding it. Okay, hold it up there. I've got the hose in here. Hose is in there, and I just take one deep breath and blow out as much as I can, okay, with one breath. Then, very carefully, I get the lid, which I just lost. Get the lid, put it back on, still underwater, turn it over, and I can see how much is left. Then we got a subtraction problem. We could do it a lot of different ways, but as a subtraction problem, if I blew out 1,500 and it was 4,000, then I'd say, well, I blew out 2,500 milliliters, right? Okay? With young students, I've done it like 2nd, 3rd grade. I've done it where that I ask everybody, I do it and show them, and then I ask everybody in the room, how much do you think you could blow out? What's your vital lung capacity? And it's called vital lung capacity because it's the amount of air you can blow out without collapsing your lungs. It's how much you can possibly blow out and still be alive, okay? So that's your vital lung capacity. So I asked them to estimate what theirs is. And we've made a graph, and we'll have, you know, Jose and Mary and Jane and all the people and what their estimate is along a graph. Then we have all the kids, they're really excited by that time, have each student come up, and they're all go, yay, 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 whatever, you know, and they blow out as much as they can, and then they graph what they thought they could do and what they did. If you have a kid with asthma, don't let them do it, okay? Find something else for them to do. They can be the water holder or something, but don't let a kid with asthma do it because that can cause you a real problem in them too. If you've got older students, they can do it themselves, and what I've had them do is sit around, like we've done it on the playground, where the kids sit around the tub, and everyone has their own straw, and you fill it all up, and each kid takes their turn doing it around, and they'll do it like 3 times, and then they get an average. And that's a really nice thing for math, because all of a sudden you see average has more meaning. Because lots of times, like measurement, averaging is something they do a couple times in the book, and they don't do it anymore because there's really no connection or relevance to it. So this way, they're seeing, they can even argue about their average. Because I had one that was, 4,000 and one that was 2, and that's not fair. So maybe then they need to do it again, and that scientists do it more than 1 time, and that's why they're doing it 3 times. Does that make sense?
Wow. Okay, now I need the lid again. Okay. Take that out. So it was 4,100, and now it's below the lowest mark, which is a problem. We needed ours marked more. Maybe it's pour it in there and see what it is. Yeah. See what it is. Okay, so we started with 4,100. No, it was just up to 4,100. A little bit less than 500 milliliters. So you basically did 3,600 for your first try. We're only going to do like that. Oh, you're not going to do the 3?
You guys doing okay? Every bit of it's gone?
Yeah. I only fill it up to the top mark.
You probably.
I'm not sure how much that is.
Yeah, the top is 4,000.
4,000.
So yeah, you might want to do it again or not. It's up to you. Fill it all the way to the top.
Fill this all the way up?
Yeah, all the way.
Okay.
You see how much nicer it is to do it outside?
Yeah. It's good to be outside.
Yes, it is. It feels good too. You're supporting me. Now you got to put the lid on.
Take another hand to hold that.
Yeah. There you go.
There you go. Oh no! Oh, it's just pretty little. It'll still work.
Maybe the hose is green.
Yeah. No, we don't have finished. Yeah. There we go. There goes all of it. Yeah.
I've just got a big lung capacity.
Yeah, I think so.
Someone would. Someone, yeah, hot air.
Okay, comienzo. Total volume of
Oh, 3rd grade's a nice grade. They're so pretty cute kids.
Son casi 1,000, digo, son todo 4,000 menos 500. Son como 3,500.
Okay.
¿Ok? Tú empieza. En 1 minuto.
¿Cuál minuto? Lo que puedas.
¿Qué? ¿Lo que puedas? Sí.
En una sola.
Cuando ya no puedas, lo sueltas.
I'll say I can blow it out.
Bien, muy bien, sí, sí, sí. El parte de ópera. Saca ostras en Acapulco.
Pues cada uno son 500. Sí. Entonces son 1, 2, 3, 4, 2,500.
She thought all she could do was 1,000.
I know. Okay.
Okay, lady.
Now what?
She's gonna do. We'll hold it just a little bit.
Yeah, but it's not going back, so now what?
Yeah, we gotta refill it, don't we? Don't we turn it over and let it fill back up?
Que igual podría ser lo que llevan menos de
So we don't have to put. So 4,000 minus 1,000.
Have a go at pulling out.
Ready? Water the plant. More than
More than you thought.
Oh, yeah.
And the trick was to take this back out again.
Sorry.
Measure what you start out with about 3,700 and then below 2,000. So maybe 1,800, 1,900 milliliters.
Non-smoker.
That's right, non-smoker.
Now that you've seen how much fun this activity is, let's check out the facts. Breathing is accomplished by muscles of the chest and diaphragm that change the volume and pressure of the chest cavity. Your vital lung capacity is the amount of air that you can force out of your lungs in one breath. If you force it all out, they would collapse. People differ in the amount of air they can blow out of their lungs, but nobody can blow it all out. So what are some extensions? Do lung diseases increase or decrease the vital lung capacity? They might research this. Do larger people have larger vital lung capacities? What about older people? And how does exercise affect your vital lung capacity? Explore.